pigs gone wild. Researchers found that Texas has the worst feral hog problem in the entire country.
Everything began with a few pigs on a ship in the late 1400s. Today, that small beginning has grown into a nightmare for more than 52 million Texans. The deep tears in the soil, the crushed vegetation and the fields warped, as if an invisible blast had swept across them all, revealed the same truth. This is no longer a nuisance animal. This is an invasive force overwhelming the entire ecosystem.
It's estimated about 6 million feral pigs are roaming America, causing an estimated $1.5 billion in damages.
But what worries researchers most is not just the destruction. It is the astonishing adaptability of a biological super-organism that has already surpassed every control model humans have tried to use against it. 5 centuries that shaped an invasive species. The feral hog crisis in Texas began more than 500 years ago, with small decisions made by people who never imagined they were creating a creature capable of reshaping an entire state. The story starts in 1493. On his second voyage to the West Indies, Christopher Columbus brought several domestic pigs on board. To him, they were nothing more than a mobile food source, animals that could feed themselves and reproduce quickly when the ships reached unfamiliar shores. But those seemingly harmless pigs escaped, went wild, and quietly formed the foundation of the first feral populations in the New World. Nearly half a century later, in 1539, the explorer Hernando de Soto pushed deep into what is now the southeastern United States with a much larger herd. His expedition traveled hundreds of kilometers through dense forests and rough terrain. Along the way, many pigs escaped, were abandoned during conflict, or simply vanished into the wilderness. By the time his journey reached the region that would later become Texas, these lost animals had already begun forming independent, self-sustaining groups. During the following century, European settlers and indigenous communities practiced open-range husbandry, turning pigs loose to forage freely and collecting them only when food was needed. This created the perfect opportunity for domestic pigs and early feral populations to interbreed, producing lines that carried traits ideal for wild living. They became stronger, more alert, and increasingly capable of surviving without human help. A true turning point arrived in the 1930s. Wealthy landowners, hoping to introduce more exciting game animals, imported Eurasian wild boar. These were larger, tougher pigs with thick coats and strong fighting instincts. Landowners believed their fences would contain them. They were wrong. The imported boar quickly broke free and met the feral populations that had existed for centuries. When these two genetic streams mixed, something new emerged, a hybrid hog with greater endurance than either parent. Scientists call this hybrid vigor, meaning the offspring inherit the strongest traits from both sides. From domestic pigs, the hybrids gained rapid reproduction, large litter sizes, and incredible adaptability. From Eurasian boar, they inherited muscle strength, aggression, cold resistance, and an unusually sharp sense of awareness. By the end of the 20th century, Texas was no longer dealing with the escaped farm pigs of the colonial era. It was facing a completely new organism, a hybrid population shaped by 5 centuries of natural selection, human mistakes, and unpredictable crossbreeding, a biological structure that defies control. Once these hybrid populations became established in Texas, researchers realized the threat was not only their sheer numbers. The real challenge came from their biology, a body and behavior shaped almost perfectly for wild survival and nearly immune to conventional control methods. Today, more than 2.5 million feral hogs roam across the state. Yet they bear little resemblance to the pigs people know from farms. Many weigh between 50 and 180 kilograms, and the largest individuals sometimes exceed that. Their tusks can grow several inches long, and a thick shoulder shield of tough tissue covers both sides of the body, enough to deflect small caliber rounds and protect them during territorial fights. Their bodies are built for strength and endurance, but their adaptability is what alarms scientists most. Feral hogs do not simply run fast, dig well, or climb when needed. They learn. They remember the sound of traps, recognize helicopters from a distance, and avoid places where the herd has been hunted before. A hog that escapes once will not return to the same trap, and its experience quickly spreads to the rest of the group. Their social structure gives them another advantage. Females and their young live in large groups known as sounders, guided by the oldest sows. These leaders store knowledge of food sources, shelter, and danger zones, then pass that information to new generations. Male hogs tend to roam alone across enormous areas, sometimes tens of thousands of acres, unintentionally carrying genes and diseases far beyond their birthplace. Reproduction pushes the threat even further. A female can breed at only 6 months old. With a pregnancy lasting just over 3 months, she can produce 2 litters a year, each with 6 to 8 piglets. This allows the population to grow even when hundreds of thousands are removed annually. If culling does not exceed 70% of all hogs in a year, the population can fully rebound in 1 or 2 years. All these traits, from physical strength to intelligence, rapid learning, complex social behavior, and explosive reproduction, merge into a troubling picture. Feral hogs in Texas are not ordinary nuisance animals. They are a fully functioning biological system, efficient enough that traditional control methods fail again and again. Texas is therefore not facing a simple, invasive species. It is facing a survival machine, shaped over centuries and now operating far beyond what humans ever expected. An ecosystem unraveling from the ground up. When people think about the damage caused by feral hogs, many imagine destroyed crops, torn up pastures, or gardens covered in hoofprints. But these are only surface-level wounds. The real consequences lie much deeper, hidden in the soil, the water, and the natural structure that keeps Texas functioning. Feral hogs eat many things, but their most destructive behavior does not come from their appetite. It comes from their snout. They dig relentlessly for roots, bulbs, insects, and anything edible beneath the ground. When a herd passes through an area, the land behind them often no longer looks like soil. It resembles a field overturned by a plow, and it can happen overnight. This digging may seem simple, but it is powerful enough to alter entire soil systems. Once the surface layers are broken apart, rainwater no longer sinks into the ground as it should. Instead, it flows across the top and carries away the richest soil. This increases erosion, fills streams with sediment, and forces downstream areas to absorb far more runoff than normal. In some regions, scientists have measured a nearly 50% drop in water infiltration after hogs move in. Water is where the damage becomes even more visible. Since hogs have no sweat glands, they must cool themselves by wallowing in mud in shallow pools. This draws them toward creeks, ponds, and wetlands, places that serve as essential control points for the entire ecosystem. There, they leave waste, churn the mud, destroy vegetation along the banks, and cloud the water. A well-documented study in Alabama found that bacterial levels in watersheds with feral hogs were up to 40 times higher than in those without them. In Texas, where many communities still rely on surface water for farming or daily use, this is not just an ecological setback, it is a public health concern. Wetlands, often called the lungs and kidneys of the landscape, also suffer heavy losses. When the soil is turned over, native plants fail to recover, and invasive species take their place. This creates ecological gaps in which plant communities collapse, grow back, and collapse again, never returning to their original state. As this cycle repeats, its native wildlife declines. Hogs eat the eggs of ground-nesting birds such as quail and wild turkey, wiping out nests before they ever hatch. They also compete with deer for acorns during the fall. These acorns are a critical food source that allows deer to survive the winter. When hogs arrive first, the native species are left with nothing. A single herd can travel many kilometers and carry mud, seeds, and pathogens with them. They link ecosystems that should remain separate, creating a chain of connected impacts stretching for hundreds of kilometers. Because their numbers are so high, anything they damage today has no chance to recover before another herd arrives. This is why scientists use a striking term to describe feral hogs. They are reverse ecosystem engineers, animals capable of destroying in a few nights what nature needs decades to build. And even this is not the most dangerous part. The destruction they cause on the land and in the water is only the beginning. Hogs also carry pathogens that can move from the wild into farms, then into the food supply, and eventually into human lives. The hidden network of disease. Feral hogs move constantly through grasslands, wetlands, farms, ranches, and even suburban areas. Along the way, they touch mud, water, carcasses, waste, and livestock feed. Each of these contact points is a chance for pathogens to spread. A single herd can create hundreds of these points in 1 week, enough to turn a minor infection into a large-scale outbreak. Scientists worry not just because hogs travel widely, but because they can carry many diseases at the same time. Feral hogs host dozens of bacteria, viruses, and parasites. Among them is brucellosis, a disease that causes miscarriages in livestock and long-lasting symptoms in humans, especially hunters and anyone who handles meat without protection. They are also carriers of pseudorabies. This virus does not infect people, but it can kill dogs within days, making the use of hunting dogs extremely risky. There are other silent threats as well. Some waters used for wallowing may hold E. coli or disease-carrying ticks in concentrations dozens of times higher than normal. From there, the contamination can flow downstream into farms or residential areas, creating a problem that spreads far beyond the initial site. Yet the most alarming threat comes from a virus that has not reached the United States: African swine fever. It is harmless to humans, but almost always fatal to pigs. If it enters Texas, feral hogs would become the perfect ignition point, spreading the virus through the entire livestock industry and collapsing pork production within months. Europe and China have shown that once this virus infiltrates wild hog populations, eliminating it becomes nearly impossible. No one can control an animal that is this intelligent and this mobile. Feral hogs are not just a physical invader. They are a moving platform for disease, connecting places that were never meant to be connected. In this network, even a small pathogen can find a fast and efficient path outward, far beyond what any human control strategy can match. This leads to the most difficult question of all. If the hogs themselves have become a spreading system, how can Texas ever hope to stop them? A battle trapped in conflicting interests. After seeing the damage to soil, water, and public health, it is easy to assume that the government only needs to enforce stricter measures, and the problem will fade. The reality is much more complicated. Texas is fighting an extremely intelligent invasive species, while at the same time wrestling with its own economic systems, land laws, and human motivations. The first obstacle comes from the question of who actually benefits from the presence of feral hogs. For years, private landowners have turned them into a reliable source of income. Helicopter hunts, guided night hunts, and thermal scope rentals have become an entire industry. People travel to Texas simply for the experience of hunting wild hogs, and the money flowing into these services is significant. This creates a difficult paradox. If feral hogs are eliminated completely, the revenue disappears. As a result, many large properties do not truly want the animals gone. They rarely admit it openly, but they often manage their land to maintain huntable numbers, rather than aiming for full eradication. The second issue lies in land ownership. Texas is a state dominated by private property, which means control efforts depend on voluntary cooperation. One ranch may spend tens of thousands of dollars trapping hogs, while the neighboring property does nothing, and may even protect the hogs to support hunting activities. The hogs simply move to the areas with less pressure and return later, nullifying any progress. Ecologists refer to this as the source-sink dynamic. Areas with heavy culling become sinks, while places without control efforts become sources that continuously replenish the population and undermine surrounding efforts. Trapping and shooting also fail to keep pace with reproduction. Hundreds of thousands of hogs may be removed each year, yet the population still grows. To keep numbers from increasing, more than 70% of all hogs must be removed annually, a level that is nearly impossible to achieve across the entire state. Small-scale efforts may offer temporary relief, but in the long run, they function more like mowing grass. A few months later, everything grows back exactly as before. Even extreme measures are difficult to implement. In 2017, when Texas considered using the poison warfarin, both hunters and conservation groups immediately opposed the idea. Hunters worried about contaminated meat. Conservationists feared collateral deaths of eagles, coyotes, and scavenging species. The backlash was so intense that the proposal was withdrawn entirely. Technically, chemical control could work, but human resistance prevents it from ever being deployed. All of this leads to a hard truth. The battle against feral hogs is not only a biological struggle, it is a human one, shaped by incentives, competing interests, and fragmented decisions. These elements together allow the species to continue expanding, despite all the technology Texas has brought to the fight. The North American superpopulation and the endless war. So far, the feral hog crisis may seem terrifying enough for Texas alone, but the state is only facing part of the problem. In the north, another force is moving downward, a lineage of hogs larger, tougher, and forged by the harsh environment of Canada. As the two populations draw closer, scientists believe we may be witnessing the beginning of something entirely new on a continental scale. The story of Canada's super hogs began in the 1980s and 1990s when farms across the prairie provinces imported Eurasian boar for meat production and commercial hunting. When the market collapsed, many animals escaped or were released. In the cold climate, Bedim Chatsuka in Kolpwe, they evolved larger bodies to retain heat, following a long-established biological principle that animals in colder regions tend to grow bigger. Some adults exceed 250 to 270 kilograms, with thick coats and an ability to dig winter dens beneath the snow. This cold resistance breaks the old assumption that winter would limit their spread. Instead, northern hogs have expanded faster than expected, enlarging their range by tens of thousands of square kilometers each year. They are approaching the United States border, carrying traits Texas hogs have never needed to develop: remarkable endurance and massive size. The greatest concern is what happens when these two gene pools meet. Texas hogs already possess rapid reproduction, adaptability, and intelligence. Canadian hogs bring size, strength, and cold survival. If these traits merge, the result could be a North American superpopulation, animals capable of surviving northern winters and southern heat, moving freely across the continent without climate boundaries. Models suggest that only a small amount of northern genetic influence could expand the potential habitat of feral hogs to as much as 70% of the continent. Instead of a localized Texas problem, the invasion could stretch from the Great Plains to the eastern states and even down to the Mexican border. The weight of this threat becomes clearer when looking at the mathematics of control. Texas has achieved temporary success in some counties, reducing populations to nearly zero. This proves eradication is possible, but maintaining that success is another challenge entirely. 1 year without pressure allows populations to rebound. One uncooperative neighboring property allows hogs to return. One wave of super hogs from the north can erase years of progress. This is why many researchers describe the fight as an endless war, not because humans cannot win, but because the enemy has evolved beyond the boundaries humans once relied on: winter, geography, local action, and the limits of conventional hunting. Texas, and North America as a whole, must now confront a difficult reality. The battle against feral hogs has no clear endpoint. It resembles permanent maintenance, where future generations must invest effort, resources, and time simply to keep the damage within tolerable limits. When a single species becomes a superpopulation that stretches across an entire continent, the question is no longer how to eliminate it. The question becomes whether we can still control it at all, or whether we are only running to keep up in a race that nature began long before we understood what was coming.